In this session, we're going to talk about exception handling in PowerBuilder. I do not work for a peon, therefore this legal disclaimer. First, I'm going to talk about the basics of exception handling. Then I will introduce the Informaticon exception framework, a solution we came up with to facilitate its usage in PowerBuilder. I will do some demonstrations, and I will talk about the future development. In the end, I'm going to answer your questions. Before we start, I'd like to introduce myself. I'm Simon Yutzi, and I've been using PowerBuilder for 7 years. My work focuses on DevOps processes and tooling for PowerBuilder applications. Together with my team, I developed a bunch of libraries for PowerBuilder. Some of them are publicly available under MIT license. Others will likely follow in the next months. In the last year, my main focus was on the development of a continuous integration and deployment pipeline for our PowerBuilder projects, which we are currently rolling out. I'm also working on a package manager for PowerBuilder, which will be released next year. Because of my work, I've got experience in DevOps architecture and software engineering. My main programming languages are Go and PowerBuilder, and I'm also interested in IT security and Linux operating systems. Informaticon, the company I work for, develops an ERP system for small and medium-sized businesses. We have offices in Switzerland and Germany and approximately 80 PowerBuilder software engineers. Let's jump into the basics. What is exception handling, and how can we use it to write better code? Exception handling is all about separating the error handling logic from the business logic in your program. It improves error messages through, I sometimes call it, alternate return values. We also can force others to deal with exceptional situations and not forget to check a return value of a function. So imagine you want to go to work and you take your car to drive to the office. Usually nothing special will happen on that way and you will arrive on time. But one day, maybe, there's a construction site blocking your way. And what you're going to do is you're going to assess the situation and probably going to take a detour. And this analogy also is applicable to source code. You have a plan in your code, the standard workflow, and then there are some exceptional situations that could happen on the way, and that's exception handling. The art of exception handling is that you don't have to care about exceptional situations when they occur, but when you're able to solve them. To start a process, you have to first create and throw an exception. And that's exactly what you can see on the left side as picture and on the right side as PowerBuilder code. For this, in PowerBuilder, you have a special object type, it's exception. So you create this exception, you write your error message into this exception on the third line, and then you throw it. So let's assume you have this code snippet somewhere in your code base. So you have a data window where you call an update, and you have a commit. On the left side, this picture is there to visualize the code flow, so it goes from top to bottom. So what we want to do is we want to check the return value of this update statement, because if the update fails, we don't want to do a commit, but we want to roll back. So that's what you can see on the right side now. This PowerBuilder code does exactly that. So it creates an exception in case the update statement fails with the error message update failed, which is probably not a good error message, but it's just an example, and then it throws the exception away. If you throw an exception, somebody has to care about it, or to be more precisely, somebody has to catch it. What we can see now is a new statement structure with a try, a catch, and an end try. All the code that we've seen before is now between the try and the catch block. Between catch and end try is a lock function call and a rollback. This code is only executed if an exception occurs between the try and the catch block. And the smart thing about exception handling is that if this throw statement is executed, all the code after it won't be executed, but it will directly jump to the next catch block, where it does, in this case, this rollback. So if the update is successful, a commit will be called, and then it will exit this function. It won't execute anything more. But if the update does fail, just a rollback is executed. It's like an if-else statement. Now, why does that make sense? I could just do an if-else statement, right? The thing is, usually you don't write code like this. So usually you don't have the throw and the catch block in the same function. But what you do is you just write the code that's gray now, the if update fails, then throw. And that's all you do in your function. And what does happen then is, for example, you can see that here with the save function. If you try to save, PowerBuilder will show a compiler warning. Exception type exception must either be caught in this method or declared in the throws clause. So the caught in this method means that we do what we've seen before with the catch block, or there's a second possibility, we can declare that we want to throw an exception. And that's how it looks like. So you have a function call, for example, of try what throws an exception, and you that called this function will care about the exceptional situation. And to achieve that, you have to declare it in the of try what, or in our screenshot in of save function, that you that this function is able of or capable of throwing an exception of type exception. And if you do that, you don't have to catch it. I created an example program to demonstrate exception handling. It's a simple calculator. It just sums up numbers, like 15 plus 85 is 100, but it also supports negative numbers. And it has a flaw. It doesn't support strings, or it doesn't react appropriately to string input. It just assumes that A15 is 0, and therefore the result for A15 plus 85 is 85. I think the expected behavior would be to show a message box or an error message in the result field or something like that. And that's what we'd like to achieve now. How does the code work? In the clicked event of the run button, we can see that it just calls the of_add function, and the arguments are just the text of the left and the right box, input box. In the of_add function, we call of_to_int, like we convert the string value to an integer, and for both arguments. And in the of_to_int function, we can see that it uses the integer function of the PowerBuilder runtime environment. If you read the documentation of this function, you will find out that for string values, integer returns 0. So if it's not a number, the result will be 0. And 0 is invalid in this case, because if the argument was 0, this function would return also 0. So you can't differentiate between the two possibilities. So we have to deal with this. The question is what we do here. We could return an error code like -1. The thing is, of_to_int also defines -1, so it's a valid return value. The only possibility we have is returning null. But that's not beautiful either, because null is like a virus. If you concatenate strings and one of the strings is null, the entire result will be null. And that's something that you usually don't want. You can deal with it by just checking every return value, but then you have to store it in a variable, and that's probably something that you don't want to do either. The other thing is that null is the only possibility here to return. And if you have multiple error cases, you maybe would like to differentiate between the different possibilities. So we have to use exceptions. We instantiate a new exception and write an error message into it. And then we throw it. But if we try to save it, the PowerBuilder compiler will show this error message. Yes, we could write a try catch here, but then we will end up in the same situation. We have an error, but we can't deal with it. So we have to delegate this problem to the caller function. And that's what we do now. And if we save that now, the function is valid. There's no error here, but there's another coming up now. The PowerBuilder compiler says that in OF_add, I have the same issue. And that's obvious because we called OF_int, which declared exception as in the throws clause. We can't deal with the error here too, so we have to write it over there. And same procedure again for the clicked event. But here we can deal with this problem. We just write a try catch. And what we could do now is, for example, we write an error message into the result box. And maybe even a message box. And here we can unpack this exception error message again. And if we run this example, that still works. And now we can see error and that A15 is not a number. And that's a useful error message. We can enhance our example. We didn't deal with null values, so we could check that too. It maybe makes sense to remove this one and declare it up here, so we can reuse it again. And then it's perfect. And there could be other error states. For example, if OF_int or ls_int is a number, but it's a long, so we can also enhance our code with those error situations. So in this case, it's not beautiful, but it's a possibility to do it like this. And we don't have to change anything except of the function where the error case occurs. So we just enhanced our calculator with better exception handling without changing the OF_add function, the display. It all just works as before, and all the possible error states are now covered in the function that can detect it in the OF_int, and in the function that's able to solve it in the user interface in the clicked event of the button. There are some other exception handling related features that you can use. One is the special exception, so you can define your own exception types. For that, we just create the standard class object that's derived from the exception. And we don't have to change anything, it's just the name that makes it useful. So we just call it special X. And in the try clause, we can now use this special type of exception to differentiate between possible error states. So we can have like a choose case here. where we maybe just change the result, but or define the error state, but we don't show an error message, for example. The other thing that's sometimes useful, not in this case to be honest, is the finally statement. The finally statement is there to be sure that some code is always executed no matter what happens in the code, in the function. As I said, it doesn't make sense for this case, but if we, for example, open the file, we have to close the file. And what we usually do is we just call file close. But there's an issue. If we return here, and so we can put it here, and even if there's a return statement over there, the file close event is called after the return statement. So the function returns 0, and before the PowerBuilder runtime exits the function, it calls all the code that is in the finally block. You can also use this without catch statement. So we could also write try finally and try. So you don't always have to catch if you'd like to use finally. So with this concept, you not only can delegate exceptions to the caller, you can even force the caller to care about possible exceptional situations that could occur in your function. And that's what makes it so elegant to use it. There are some situations. What it means is that in PowerBuilder code, you don't have to catch runtime errors. Of course you can. It also makes sense to do that, but you don't have to do it somewhere in your business logic because, for example, if there's not enough memory, that's not something that you can solve in your business logic. That's probably something for like really base function of your program, or maybe you have even to stop your whole application. So if you throw a runtime error, you don't have to declare it. You can just do it. If you want to throw an exception, you have to declare it, or you have to catch it yourself. So if we compare exception, or we also can call them checked exceptions, and runtime errors, we can also call them unchecked exceptions, then the exception is foreseeable, while a runtime error is something that's unexpected. You use exceptions mainly for external interfaces and to enforce exception handling. And runtime errors, that's something that you use for programming errors, or if it's hard to enforce exception handling or doesn't make sense. Generally speaking, exceptions are recoverable errors, like an update statement failed. That's easy. Maybe you have to close the module that tried to call that update statement, but you don't have to stop the whole application. And runtime errors, that's something that's hard or even impossible to recover from. Like I said, for example, if you're out of memory, you're not going to solve that in your application. But let's move over to the Informaticon exception framework. The motivation of writing a known framework just for exception handling was that there are multiple issues in the existing solution. First, you have to write a lot of boilerplate code. Like just to throw an exception, you have to write at least 4 lines of code. So for 2 lines to declare and create the exception, 1 to add the error message, and the 4th to throw it. And we thought that's too much. And the second, and that's the more important of the two, is in an exception, you can just store a string. Even though it's in an object, PowerBuilder just allows to store a string into an exception. And we wanted to add more context information, for example, where it happens, why, or what additional information could be helpful to debug the code. So exception framework is basically just a PBL that you can add to your target. It adds exception management possibilities, like it makes it easier to create exceptions or to store information into them. It also adds call stack analysis possibilities, like you can see the call stack and other information that's important to you, to your exception automatically. And it also allows you to share exceptions, like to export and import exception information. To achieve that, instead of the standard exception type that's provided by PowerBuilder, we have our own exception type, and we have an additional exception information object. It's the UEXF error data. And this object we store in a special exception. The exception framework comes with a new variable, the GU_E, which provides several functions. One of them is OFNewError. With OFNewError, you can create a new error data object, in this case with the error message. You can also add additional information into a key value store. So you have an OFPush function, which you can call multiple times on the same object, and where you can add a key and a value pair. The value can be anything, like it can be a number, an object, a string, a data window, just everything that you could imagine. The error data object that we've just created, we can then store in an exception or a runtime error. We use exception framework specific exception and runtime error type, which depends on either exception or runtime error object type of PowerBuilder. That's needed because we want to store special data, and as I mentioned before, that's not possible in the standard objects. So we have this U_EXF_RE for runtime error. The exception, or in this case the runtime error, you can then throw using the throw statement, as we've seen it before. In this case, we threw a runtime error, but there are other possibilities. The exception framework comes with a bunch of different exception and runtime error types. The most important are probably the RE, the standard runtime error, then the database error, which we use for failed update statements, then the not implemented error we use to create abstract classes where you are forced to override the function. Then we have the standard exception, and for example the input-output exception, which we could use for network traffic, where errors are foreseeable and you have to handle and take care of them. You probably not only want to throw exceptions, but also catch and display them. And that's why we created a special exception dialog. That's what you can see here now. That's an exception that was catched and then displayed using the OFDisplay function. You can see the standard message, an error occurred, and then the specific error message that was stored in the exception. Additional information that was pushed to it can be investigated by clicking on this magnifier symbol. You can also send it by email, copy to clipboard, or you can even store it or export the whole information from the exception to a file. Let's go back to our example program. We'd like to implement the exception handling process using the exception framework. So we go to our GitHub repository of the exception framework. There we have under releases a zip file. And what we need there is just the DLL and the PBL file. I could use the whole thing as a demonstration application, but in our case, that's not what we need. So just those two. And then we go back to PowerBuilder and add it to the library list. And now if we patch the exception framework, we also have to declare a global variable, the GU_E. We do that under in the application object. and we have to instantiate it. So the exception framework is patched now, but we want to use it in our code. So we go to our code, and first we want to change the way the exceptions are created. So we don't need this anymore. And we directly throw the exception in one line. And we do the whole thing over again for all the possible error states. That's it. Here it's just the main improvement is that we don't need that many lines as before, but we can have also another window to show the error message, and that we can also use. So we go to our clicked event again, and instead of just opening a message box, we can now do this. And that's it. So I can catch the exception as usual, so I don't have to stick to or use the new exception types. I can catch the parent exception, and with that also all the children, like the u_exif_ax is also catched here. So let's run it again with a character now, and we can see the same message again, but we can also look up the details. So what we can see is the exception was created at 1748, and here we can see the call stack. So the clicked event is the first, or the topmost command that was executed, which called OF_add, and OF_add called OF_int on line 2, and in OF_int on line 11 the error was created and thrown. In our case, it's obvious what went wrong, but sometimes the call stack is so deep that you have no idea what happened if you just get the error message or the exception from the innermost command, like from the OF_int function. So maybe there's some context information that would be useful to understand the error better. So we go to OF_add and we enhance our exception. So we catch it. And we rethrow the exception, or we nest the exception in a new exception. So of course I could just throw it again like this, and maybe change the message before like this. But that doesn't make sense, because like this we're gonna lose information. So we do a nesting, an error nesting. For this we create a new exception. And we add the catched exception to this new exception using the OF set nested error function. We can also add context. For example, the arguments would be useful, maybe all the arguments, not just the ls left, but also the ls right. And we can use this using the we can do that using the push function. So we push the needed variables to this exception. And that's it. So if we call that again, we can now see the outer exception, the OF@add exception on line 5 with the error message, calculation failed, and we can see the left error, the left argument, the right argument. We can see more information that's not that important. I mean, the message we've already seen. Theoretically, there's a message number, which we don't show here, or the type of the exception. And we can also see the inner exception, this one. And in there, we have the original exception that is nested, like the call stack of the nested exception, as well as the message. You can literally save everything in an exception. In our case, we just stored the left and right argument of the OF@add function, but we could also, for example, store the reference of the window to the exception. And we do this by just calling OF_push again. With the window reference. Exception framework doesn't just automatically converts everything to a string or a string representation. So in this case, it just shows no string representation available. So it couldn't serialize the window. If we want to have something useful in the exception, we have to serialize it. And there are multiple possibilities, but the standard approach is to write an OF_toString function, which returns a string representation. Like this. For example, the title and maybe the class name. And the exception framework automatically calls this function if it's available. So we can now see foobar is now a string, and there we can see it's the window PPNI demo of the type W main. We can also copy an exception to the clipboard or send it by email, but the most important functionality here is probably the save to disk function. So let's do this. We choose a location to store the file, the exception file, let's call it test. Then we go to desktop and we can see this file. It's just a JSON file, but it's hard to check out an exception like this. So we wrote a simple program to open this EXAF file. So load from file, then we can choose it. And now we can see the whole exception again. And that also works hours, days after the original software and exception message was closed, because everything that's available in an exception is stored to this JSON file. Even the database state, like if you have an open update statement, this information is also contained in the exception. So technically we could connect to a database here, like a development database, and then call the fire the update statement again, like data window.update, or we could show the update statement or the data window syntax of the data window. And that makes it really useful for analysis of some complicated support cases, like if you have data has been changed between retrieve and update errors, you can actually check out the exact issue of this exception. There are also some limitations to take care of. You have to be really careful when using the post command. You cannot catch exceptions or runtime errors of functions which were called using the post command. Instead, in such events, the application object's system error event will be fired and your application may crash. Dynamic calls are dangerous too. The compiler won't warn you if you call a function which declares an exception in its throws clause. So you cannot force others to deal with exceptions if they use dynamic. Like with the post command, if an exception isn't catched in these cases, the system error event of the application object will be fired. So dynamic and post can cause your application to crash without any hint why it happened. Therefore, it makes sense to program the system error event and at least display the exception. For this, the exception framework provides you with the OFGetLastError function. I also suggest programming the database error events to improve error analysis. There is one on the data window, on the data store, and on the transaction object. With this, you can write fancy error analysis features. At Informatikon, for example, we wrote an analyzer function which shows why a row has been changed between retrieve and update error occurred. So in this example, the name of an address has been changed after the data retrieval. Sadly, we cannot hide or catch every PowerBuilder native error message, for example data window expression error. We hope that Apeon will improve the situation in the future. Despite these limitations, exception handling together with the exception framework allowed us to write cleaner and better maintainable code. It also helped us tremendously to improve our error analysis capabilities. If you're interested, feel free to use our exception framework in your projects. I'm also open to any question or suggestion. Feel free to open an issue or to send a pull request on GitHub or even to write me an email. I thank you very much for your attendance and I now look forward to answering your questions.